Today we're going to be talking about lesson 6.5, which is on rhombi and squares. So what is a rhombus? It's a parallelogram with four sides that are congruent. And it has all the properties of a regular parallelogram, along with these two theorems we have here. It says if a parallelogram is a rhombus, then its diagonals are perpendicular. So essentially what it's saying is AC and BD form 90-degree angles. Perpendicular, their slopes would be opposite reciprocals of each other. It also says if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. Okay? So you'll see that angle 1 and angle 2 are going to be equal, as are 5 and 6. So would 3 and 4, and so would 7 and 8. All of those angles, okay, 1, 2, are going to be equal to each other. 3 and 4 are going to be equal to each other. So are 5 and 6 equal to each other, and 7 and 8 are going to be equal to each other as well. Alright, so let's look at an example right here. It says the diagonals of a rhombus in F, G, H, J intersect at K. Use the given information to find each measure or value. So we know this is a rhombus. So we know that right here it forms a 90-degree angle. Those are perpendicular lines. So it says if F, J, H is 82, okay, if that's 82, find the measure KHJ. That's going to be this one right here. Okay, well we know that this big angle right here is 82. And we just said that in a rhombus, the diagonals are going to bisect the angle. So this angle right here, okay, KJH, is going to be half of 82. So 82 cut into two pieces is going to be 41. So I know that this one right here is 41 degrees. Okay? I also know that this angle right here, angle K, is going to be 90 degrees. Okay? So together, those two angles add up to 131 degrees. Now, why does that help us? Well, because this triangle right here has to add up to 180. So what I'm going to do is I'm going to take 180 minus 131, and I'm going to find out that angle KHJ is equal to 49 degrees. Next one, letter B, says if GH is x plus 9 and JH is 5x minus 2, find out what x is. So if I look up here, okay, I'm going to get rid of all of this right here so you can start over fresh. Okay, so if I look right here, it says that GH right there is going to be x plus 9. And JH right there is going to be 5x minus 2. Find the value of x. Well, if you think back to what a rhombus is, and since we know that this is a rhombus, all four sides are going to be equal to each other, which means that x plus 9 is going to be equal to 5x minus 2. Now it just becomes a moron problem that we can solve. Subtract x from both sides, and I get 9 is equal to 4x minus 2. Add 2 to both sides. And so I get 4x is equal to 11. How do you get x by itself? You divide, x is equal to 2.75. Notice they didn't ask how long each side is, they just asked x for the value of x. Here's a couple problems for your guided practice. Feel free to try those right now. So the next thing we're going to talk about, we talked about rhombus, now we're going to talk about a square. Well, a square is a parallelogram with four congruent sides like a rhombus, but also four right angles. So recall that a parallelogram with four right angles is a rectangle, and a parallelogram with four congruent sides is a rhombus. So essentially what a square is it's both a rhombus and a rectangle. So you'll see right here, rhombuses are when you have all four sides equal to each other, rectangles when you have 90-degree angles, and then right here in the middle is a square. All four sides are the same, all four angles are right. So now there's a couple different things that happen when you have to figure out the difference between a rhombus and a square. So here, theorem 6.7 says if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So anytime you get these angles, or these diagonals right there, they form 90-degree angles, then it's a rhombus. If one diagonal of a parallelogram bisects an opposite side, then it's a rhombus. So essentially, if you have it and these angles right here are going to be equal to each other, or these two angles are equal to each other, or on the opposite sides, then you know for sure it's going to be a rhombus. Theorem 6.19 says if one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So essentially it's saying if you have this side right here and also this side right here, the ones that are connected by a vertex, if those are congruent, then it has to be a rhombus. Okay? And finally, the last one, if a quadrilateral is both a rectangle and a rhombus, then it's a square. So this one's going to help us. So if we ever want to figure out if something's a square, we have to prove that it's both a rhombus and it's a rectangle, meaning it's all four sides are the same and all four angles are right angles. All right, so example 2, prove that this is a rhombus. Okay, well it says we know it's a parallelogram. Great, that means that we know that these sides right here are parallel and these sides right here are parallel. It also tells us that JKL is an equilateral triangle. Okay? Excuse me, isosceles triangle. So since we know that it's an isosceles triangle, we know that JK and KL are going to be equal. They're going to be congruent. So prove that it is a rhombus. Okay, so let's set up a proof. So here's our proof and our statement. Okay, so the first thing, 1. Okay, we don't have to say it's a parallelogram, but we can say that triangle JKL is isosceles. Okay, so that's given information. Then since we know it's an isosceles triangle, our second step would say that JK is congruent to KL. And that's the definition of isosceles, right? Okay. And then we actually had one of the theorems. It was theorem 6.19 that said if you have two consecutive congruent sides, then it's a rhombus. So that's going to be our last step. Step 3 is going to say that JKLM is a rhombus. And if you're wondering how we got that, remember that's theorem 6.19. Box it and we are done. So not too bad, okay? Told us it's a parallelogram, that's good to know. Told us we have an isosceles triangle, which means that the two sides are congruent, and if two consecutive sides are congruent, then it's obviously a rhombus. Here's a guided practice problem right here. It says to write a paragraph proof. You could do the same if you'd like. All right, example 3. It says the key to a successful excavation of an archaeological site is accurate mapping. How can an archaeologist be sure that the region they have marked off is a 1 meter by 1 meter square? Okay, well, the first thing we like to see is that we have all four sides equal. And if all four sides are equal, it's a rhombus. Okay? Check. Okay? So we know it's a rhombus. Then what we'd want to do is we'd want to make sure if we want to see if it's a square, we'd want to make sure that all of my angles are all angles 90 degrees, question mark. And if we know that, if we find out that all four angles are right angles, then it's a square. So our archaeologists would have to prove, they'd have to go measure to make sure that all four sides, or excuse me, all four angles are going to be right angles if they want to prove it's a square. But until they can do that, we can't see if it's a square or not. Alright, here's an example having to do with a quilt. Last one, okay? This one's going to take a little bit more time. It says determine whether parallelogram JKLM is with vertices of those four, is a rhombus, rectangle, or square. List all that apply. Okay, so first off, -7, 2. I'm going to stop the video for just a second to plot my quadrilateral, and you can do the same as well. Alright, so now I have it drawn. So the first thing I'm going to check is I'm going to check the diagonals. Remember, when we have a square, the diagonals are going to be the same length. Now we can look at the picture and probably say, they're probably not the same length, but let's check them anyway. Okay, so the distance formula from J to L is this. x2 minus x1. So that would be 9 minus -7 squared plus y2 minus y1 squared. That would be 2 minus -2 squared. Okay, so 9 minus -7 would be 16 squared, and that would be 4 squared. So we have 256 plus 16. That would be the square root of 272. Alright, so now let's find the length of KM. Okay, so the distance from K to M is going to be 2 minus 0 squared plus -4 minus 4 squared, which is going to be the same as 2 squared plus -8 squared, which is the square root of 4 plus 64. That's the square root of 68. Notice these two are not the same, so it can't be a square. Okay? So we'll write not a square. Alright. So they're not a square, but that's okay. What we can check next to see is if it's a rhombus. And the way we see it's a rhombus is we're going to check the slopes of my two diagonals, because remember, a rhombus has perpendicular slopes. Okay, so if I'm going to find the slope of JL, okay, slope of JL. So JL, okay, remember y2 minus y1 over x2 minus x1. That would be 4 over 16, which is 1/4. Okay? So then we can find the slope of Km. So if I find the slope of Km, okay, it's going to go -4 minus 4 over 2 minus 0. So that would be -8 over 2, which is -4. So you'll notice that they are opposite reciprocals of each other, so this is a rhombus. Okay? So it is a rhombus. And obviously then you can tell that it's probably not going to be a rectangle because it doesn't have 90-degree angles at all four angles. So the only one in which it is a rhombus, not a square, not a